for us to move on to later topics. Area is, we're talking two-dimensional, aren't we? We're talking about the length before one dimension, but an area is where we have up and down and across, if you like. That's an irregular area. And inside of that, the space or the room inside of that 2D space or two-dimensional space, that's all area, isn't it? So it describes the size of the zone inside that boundary. That's something we should know already. If we have a square, which mine's not a very good one, if that happened to be 1 centimetre side lengths on all four sides, the area is 1 centimetre squared. If we have a rectangle of 3 meters this time by 2 meters this way, we can break that up into 1 meter squared squares. We'd have this, wouldn't we? And there'd be 6 identical squares of 1 each. So 1, 2, 3, 4, 5, 6. 6 meters squared, or 6 square meters. We have another way of finding that. The area of a rectangle is the length by the breadth, which would be in this case 3 times 2, which is meters times meters. So we have 6 square meters. So area is something that's two-dimensional in nature, and we have squared units. We saw that previously that with linear units for length, if we have millimeters, converting them to centimeters. Previous video we saw that we have to divide by 10 going in that direction. We divide the amount, the number of the magnitude by, multiply it by 10 going that way. However, with area we have something more complex. We'll get to that in just a second. Put in the other common units. Now this is something we've looked at already. Divide by 100 there, times by 100 there. So 3 meters times 100 is 300 centimeters. We have 1,000 in this conversion here. But what if we're converting square units to area? Millimeter squared, centimeter squared, meters squared, kilometer squared. Is it the same? Well, it's actually not. We've got the following values here. But where do they come from? They're not the same as the ones above. The numbers are much bigger. Can you see any pattern? So we're still times and dividing, but that one's, instead of 10, it's now 100. That one, instead of 100, is now 10,000. This one, instead of 1,000, is 1,000,000. That's the story. If we start at one of these examples, like here, where we're converting between centimeters and millimeters, looking at the example here, if we have say 1 centimetre squared like before. As we know, that's 1 centimetre multiplied by 1 centimetre. We also know that that 1 centimetre is same as 10 millimetres. And this 1 centimetre is also the same as 10 millimetres. We know to get the area of the square, we go 1 centimetre times 1 centimetre length times width, or side times side. So 1 centimetre times 1 centimetre equals 1 centimetre squared. We also know that to do the same thing using millimetres, we'd be going 10 millimetres times 10 millimetres. 10 times 10 is 100. 100 millimetres squared. But these two things both describe that area, so those are equal. So 1 centimetre squared is the same as 100 millimetres squared. And we can show the same with the others. So if we look at a neater version of that from the textbook, page 303, it shows that same thing. So copy that down as part of your notes. In the next video, we'll look at some areas of common shapes, also from page 303 of your